Okay, for the attributes, the vocab that you need to know, first thing is domain. So domain is the complete set of possible values of the independent variable, or the x values. So when you look at the three examples I have here, just to look at the domain, one way if you struggle to decide, you're really looking from left to right what x values are possible, what you can do is cover up the graph. So if I look at this first example, if I cover it up, and then I'm going to move from left to right. So as I go from left to right, I'm looking for x values. I notice there's an arrow here, so that means it's going to the left forever. So it's going to start at negative infinity, technically, in my set. And then as I move to the right, it goes to positive infinity because it's going to keep going. So to show domain, you either can write all reals, but in interval notation, we write it as negative infinity to infinity. All right, the second example. If you look at this example, again, if I cover it up and go from left to right, if I start here, I see that the leftmost point is at negative 3. It doesn't include negative 3, so I remember I use a parentheses, and then I keep going and say, okay, it started at negative 3, I'm moving to the right, and I notice then the arrow means it's going on forever. All right, the third example. If you look at the third example, as I move to the left, I see, oh, there's an arrow, so it starts at negative infinity, and as I move to the right, the x's stop at 5, but it's filled in, so it includes the 5. So I'm going to go from negative infinity to 5 with a bracket. Okay, so there's some examples of how you can look at domain starting from left to right. If you need to cover it up, that's an easy way to kind of check to see what that domain is. The range is the complete set of dependent variables, or the y variables. So let's go back up to our examples and let's see if we can fill in the range of those. So looking at these examples, now we're looking at y values. So again, you're going from up and down for the y values. So if you want to cover this up, cover it up, you want to start with the bottommost point. So as I look for my graph, the lowest point is at y value of 0. And as I go, it's going up in either direction. So my range for this one would start at 0, including the 0, to infinity. All right, do the same thing with this one if we need to cover it up. Again, lowest point does start at 0. The highest point, now it looks like it stops here, but notice on the right side it's going up still, and it goes to infinity. So the range of this one would start at 0, again include the 0, and go to infinity. Okay, so you're always just looking, all it needs is one y value to keep saying that that is the range. With this one, it starts at negative 2, is the lowest point, and it stops, this is the highest point. So as I'm going through, that's the highest point, and that point is at 3, including, so I have to put it in a bracket. So this one goes only y values from 2 to 3. All right, if you want to stop the video, try these two. Look to see what you think the domain and range of each of those are, and then I will come back and give you the answers to those. All right, so the answers to those, again, if you're checking domain of this one, there's nothing here. It starts at 0 but doesn't include it because there's an vertical asymptote there, and it goes forever to the right, so 0 to infinity. And then if you look at the y's go down forever, so negative infinity, they keep going up to infinity. With this one, left to right, negative infinity, all of a sudden you see there's a vertical asymptote at x equals 2, but then it continues on again. So the only place where it's undefined, where there is no x value, is at 2. So we say from negative infinity to 2 for this piece, and then from 2 to infinity for that piece. Notice neither of these include the 2. Same thing with the range. It goes from negative infinity to negative 1, but it doesn't include the negative 1, and then it goes from negative 1 to infinity. So that's domain and range. Increasing and decreasing and constant just means as I go from left to right. So as I move to the right again, are the y values going up? Are they going down? Or are they staying the same? So if you look at the first example I have here, as I move to the right, again, if you need the card, you certainly can use this card. As I go to the right, you'll notice my y values are going up, my y values are going up. So this is an increasing graph. For all parts of the graph, it's increasing. With this one, if you notice as you go from left to right, this is going down, so it's decreasing, and then it's undefined at 0, but then you also know it's going down here. So this is a decreasing graph. So you either can cover it up or you can just start following it along. It's going down, it's going down. Again, this is undefined, so I can ignore that piece. This is going down, decreasing. With this one, we have a few things going on. As I move to the right, this is increasing, this is constant, and this is decreasing. So to show that, I had to show it in 3 different parts. It's increasing from negative infinity. We're looking at the x values when we describe this. Okay, so from the x values from negative infinity to 1, that's where this is increasing. And then for x values from negative 1 to 1, it's constant. And then from x values from 1 to infinity, it's decreasing. So as you describe different pieces of the graph, you use your x values to describe that, the interval of the x values. Okay, again, if you would like to see if you can answer this question, where is it increasing or decreasing, you can shut the video off and think about that. All right, the answers are, though, it's increasing from negative infinity to 0. It's also increasing from 4 to infinity. Again, you're looking at the x values, so if it helps to do this and say what x values, all right, this is going forever, so from negative infinity to 0, that's where it stopped, then it starts to decrease from 0 to 4, and then it's increasing from 4 to infinity. So if it helps to move left to right to kind of figure out which intervals that is, and to remind yourself you're looking at the x values. Okay. The next piece of information is about maxes and mins. So a local max is when the graph changes from increasing to decreasing. So it's going to be going up, and then it's going to start decreasing. That's a maximum. And if the graph is decreasing and then it changes to increasing, that's a minimum. Okay, so if you look at, let's look at this last graph we just looked at. This is a local maximum because it was increasing and then it turned to decreasing. That's a local max. There's a local minimum at 4, -3. Now we say local because technically if this goes up forever, there is no maximum for the y, or there is no minimum for the y, but there is a local maximum and a local minimum. Okay? We also call those turning points. It turns. It was going up and now it's going to decrease. That's a turning point. But that's a local maximum, that's a local minimum. Point of inflection is where the graph continues in the same pattern of increasing or decreasing, but it levels off and then gets steeper. So an example of that would be right here. This is all increasing, but you'll notice that it's steeper, it's leveling off, and then it speeds up again, or it increases, it's steeper. Okay, so you should see that little, it looks like it almost is going to be a maximum, like it's slowing down, it's leveling off, and then it takes off again. That's a point of inflection. All right, the last terms are even and odd. Even function is when it has y-axis symmetry, and odd function is when it has origin symmetry. So when I look at this graph, this is an even function. It's even because when I take any point over here, and I labeled one point, I labeled the point 3, 2, if the point -3,2 is on that graph, if it's reflected over the y-axis, remember this is the y-axis, if it's reflected over the y-axis, it's even. Okay? And that has to be true for every point for that to be even. To be odd, for every point on the graph, it has to have origin symmetry, which means I'm reflecting it about the origin, which means I reflect it over the y and over the x. So if I have the ordered pair 3, 2, if I reflect it over the y and the x, the ordered pair -3, -2 has to be on the graph. So that tells me it is an odd function. So in general, if you're thinking about it, whatever your graph looks like, if it's odd, well, let me draw the even first. If it's even, if you have x, y, then you have to have the opposite of x and y over here. If it's going to be odd, whatever your graph looks like, if you have an xy here, you have to see a opposite of x and an opposite of y. Now, this could be in any quadrant, but we're just saying the negative means opposite of. So odd and even. Okay, this is an odd, that's an even. Okay, so those should be all the attributes that you need to know besides intercepts for the basic functions.